Welcome to another video. Now let's provide a solution to this problem. Now we are given 1 on the x root of 49 minus 1 on the x root of 7 equals to 20. Now when you are given the nth root of, let's say, p, the same as p raised to 1 on n. And when we have 1 on, let's say, the nth root of k is the same as 1 on k raised to 1 on n. And it's the same as 1 over k all raised to 1 on n. Perfect. Now knowing these properties, we are free to go. Now let's see how we can write this. So we have 1 on 49 exponent 1 on x minus 1 on 7 exponent 1 on x equals to 20. Now let's observe this. So we have similar one here. Now we can say 1 on 49 all raised to 1 on x minus 1 on 7 all raised to 1 on x equals to 20. All right. Now from here, we can get this one here because 49 can be written as 7 squared. So let's write this one as 1 on 7 squared all raised to, let me demarcate, 1 on x minus 1 on 7 raised to 1 on x equals to 20. So we can bring these two out, since 1 on x to the power 2 is the same as 1 on x all squared. So we can say from here that 1 on 7 all squared all raised to 1 on x minus 1 on 7 all raised to 1 on x equals to 20. Okay, so that's that. Now let's observe this one carefully. From here, anytime we're given a to the power n all raised x is the same as a to the power x all raised n. So we can manipulate this one. Since multiplication is commutative, we can manipulate it. So we can do same here. We want the 2 to be here and we want this 1 to be here so that we can take it out. So we can say 1 on 7 raised to 1 on x, and we have everything to the power 2 minus 1 on 7 all raised to 1 on x equals to 20. So we have something in common here, that is 1 over 7 raised to 1 on x. So let's take it out. Let 1 on 7 raised to 1 on x be k. So going back, I'll put k here. That will be k squared minus k equals to 20. So we have k squared minus k. Now let's bring the 20 in. Minus 20 is equal to 0. Now here, this side is k. We have squared here minus k. Then we have the 20 in. So this one is a quadratic. So I'll multiply the coefficient by the constant. That will be minus 20. And I'll find two numbers. When I multiply them, the two numbers must be factors of this number. So we have minus 5 and 4. So the two numbers, when we multiply them, to give us this, but when we add, to give us the coefficient of k, that is negative 1. So if I add this, I'll get negative 1. If I multiply, I'll get this. So we have k squared. So we have minus 5k plus 4k minus 5k plus 4k minus 20 equals to 0. So we can factorize something out here. We can factorize k. So we have k minus 5 plus 4k minus 5 equal to 0. So we have something in common. K minus 5, k plus 4 equals 0. So we can solve for k. K equals to 5 or minus 4. That's the value of k. But remember that we represented k, okay, this one by k. So let's go back and replace the value of k over there. Okay. So let's recall that 1/7 all raised to equals to k. So the first answer for k is 5. So how do you solve for x here? So we have 1/7. Let's take log on both sides since we want this one to come down. So we have log 1/7 raised to 1 on x equals to log 5. Okay, so that's the first answer for k. So when we have log a to the power n, the same as n log a. So we have this one as power rule. So 1/x log 1/7 equals to log 5. All right, so I want to do something here. So let me remove this. All right, let me remove this by multiplying both sides by x. Okay, so it's by x. So this side will go. I'll be left with log 1/7 equals to x log 5. So let's divide both sides by log 5. Log 5. So this one will go. So we have x equals to log 1/7 on log 5. But when we have log a over log b, the same as log a to base b. So this side will be log 1/7 to base 5 as the answer. Okay, now the next option as log 1/7 raised to x equals to log -4 does not exist because we can't take log of negative number. So x equals to -4 is not possible. All right, so the only solution here is this. All right, thanks for watching.